I want to show you what's so cool about this sonoluminescence reactor design. So I basically didn't do the normal prototyping process where you start with like the worst Frankenstein bench prototype and move on and on and on. And that would be like starting with a glass flask, like a spherical flask. I didn't want to go that route because I knew that eventually we want to pull heat, excess heat from this design. So we need some sort of metal that we could have like a manifold with fluid channels going through. So there's a manifold right there, has ports all over it. And then these are the hemispheres. So what's so cool about this is this hemisphere right here can be unbolted from the manifold. So you can change the geometry of your hemisphere. You could go to like a one-sided setup. You could have some sort of other cavitation designs, like a series of channels, a small little point, 2 points coming together. You could do all kind of weird stuff here just by changing these two hemispheres. It would make the most sense that I would have started with a spherical glass flask, get the sonoluminescence running, and then move on from there. But that's just not how I operate when I'm on a shoestring budget and I have huge ambitions and we have this beautiful social media network of all of you brilliant people out there. No, I'm gonna bite the whole thing off at once. So basically I came up with a manufacturable almost design, which short circuits that whole development cycle from Frankenstein to early proof of concept, like all the iterations. We do have a whole bunch of variables thrown in together. But when we really start exploring and probing and sweeping stuff, we can solve multiple variables at one time. I'm telling you, I've done this before. There is a way to do it. So essentially, once we get a stable bubble inside our system and we have a camera to look at it and we already have drivers to generate the acoustics, we're like 3/4 of the way there. So fast forward to when we get our stable bubble, we know our acoustics to get there. What you're gonna find is that we have a whole bunch of variables that are not risks to the future of the project anymore. All of a sudden, we're not stuck in a glass flask with something working and oh crap, we can't pull heat off of it. Like we'll basically be ready to go to start pulling excess heat. So this is a weird development cycle I'm pursuing here, but in the context of solving LENR as an open source community, we're not gonna use something like this. It's not gonna be like a $5 million setup that you can't get exactly right because they only made 2 of these in the history of the company that made whatever that is. What we're gonna do is we're gonna have CAD of this setup right here, and then maybe it costs a few $100s to make on your own. You download the files from the GitHub, make your own setup, or buy one from me, whatever. Let's dream for a second. Let's say a couple dozen of us all have the same design. We have spreadsheets and formulas that get us excess heat consistently. You put like $50 of palladium powder in it and you get 2 years of all the heat you want, let's say. At that point, this project is unstoppable. There's no erasing it because it's open source. It'll be out there in the ether. And we will start to see decentralized power units, decentralized home heating, and all that good stuff that'll come out of this effort. That's where it could go. We'll see what happens. Stay tuned. Adios.